Let's begin with a short story. Linda was a charming 70-year-old lady who was loved by everyone. But over time, her family began to notice something different about her. Linda seemed to be misplacing her items a lot. She was repeatedly asking questions and taking more time to perform tasks like eating and bathing. After a few tests, a physician confirmed that she had Alzheimer's disease. Linda's family was told that Alzheimer's was a neurodegenerative disease, meaning that her brain tissue would progressively get damaged, causing deterioration in memory and other cognitive capabilities, and eventually death. Linda was currently in the mild stage of the disease. Three years after Linda was diagnosed, her family began to notice some more serious symptoms. In the beginning, she couldn't recognize her own grandson. Later, her daughter had to choose clothes for her and help her get dressed. She also seemed to be experiencing hallucinations. Linda was now in the moderate stage of the disease. Six years after her diagnosis, Linda had completely changed. Her communication was limited to grunting, and she needed help with eating and going to the bathroom. She soon became bedridden. Linda was in the severe stage of her disease. In a year, she passed away as a result of pneumonia, a secondary infection that her body weakened by Alzheimer's couldn't fight off. Thousands of people like Linda are diagnosed with Alzheimer's disease every year. It is one of the leading causes of death in the world. But why did this happen in the first place? Let's talk a bit about the science behind Alzheimer's disease. Many pathological changes take place in the brains of Alzheimer's patients long before they experience any symptoms. These changes include the formation of amyloid beta plaques and the formation of neurofibrillary tangles. The amyloid precursor protein is a protein thought to be essential for neuronal growth and functioning. Normally, it is broken down into soluble monomers. However, in Alzheimer's disease, the protein is broken down abnormally into toxic monomers called amyloid beta. These monomers are insoluble, so they stick together, forming plaques that accumulate in neuron synapses. These plaques can disturb communication between neurons and also cause inflammation, leading to apoptosis or programmed cell death. The tau protein is a protein in neurons that stabilizes the microtubules, structures responsible for the transportation of nutrients, vesicles, and other materials throughout the cell. In Alzheimer's disease, the tau protein is misfolded, causing it to break away from the microtubules and clump together with other tau proteins, forming accumulations called neurofibrillary tangles. These tangles reduce the neuron stability and also prevent the microtubules from transporting essential material. This can damage the neuron and lead to apoptosis. As neurons die, the brain tissue atrophies or loses its volume. The loss of tissue in parts of the brain responsible for memory, language, and other cognitive abilities produces the symptoms of Alzheimer's disease. Thank you for watching this video, and be sure to like, share, and subscribe.